Assalamu alaikum. My name is Vadha Sadal. I hope you are doing very well. Today, our topic is about the protein simulation. We are doing some example from the book AVR Programming in C Language by using AVR 3 to 8P. So, first of all, I want to tell you about some data type. Like you can see here on the screen, here unsigned char having 8 bit, char having 8 bit, and uh, the difference between unsigned char and char that in unsigned char we have only positive integer from greater than 0. Okay, like you can see from the screen I'm highlighting here. And in char it is also include negative minus 128 to plus 127. And one unsigned char we have having 16 bit and all positive from 0 to 65,535. Here we have int also in 16 bit. You can see the data range from screen shown. Unsigned long, and float and double, these all having 32 bit. You can see from the screen. So let's move towards our first example from chapter number 7 and 7.2, where we have this there. Here you can see what we have in int main. Unsigned chart, we have make my list array. Having the in list we have 0 1 2 3 4 5 a b c d, these all are in ASCII, and we are storing in a chart z. We are dealing with the port we are dealing with the port b, you can see, and we are initializing output ddrb is equal to 0xff. And we're using here the for loop because we know the total number of element we are dealing in our array or our list is 10. So that's why I use with for loop. 0 is equal to that is equal to 0, spread greater than 10, and we are using increment plus plus. We are storing our all the array element in port b, my list here. We can also giving the delay, and by simulating and debugging you can get these output. You can see is port b, and you can see pin b what we have, and port ddrb we have all these. You can see ddrb output ff, so it's all r1111. So is port b we are using this, you can see from the screen. And also we have the proteus, we make a proteus for it. This is the proteus for the thing. Let me on off it. Here you can see, wait a minute, this you can see, that's it. Now move towards our next example. So here our example 7.4, what we are given that we have to send the values minus 4 2 plus 4 to port p. So first of all, what is notable thing is that what is shown in port b, the port in port b, the complement of second complement of 4 will be shown on port p, like it's given here. You can then run the above program on your simulator to see how port display the values here. So what you see, then see these things you are shown on your LDR whatever on you are going to show it. These things are shown on your pins. So first see the code, what is like int main void. We have given char. My num is array used here minus 4 minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3 plus 4. And we are storing all these array element in char z, unsigned char z. We are initializing port b as the output that we are going 0xff, and we're using here for loop that start from z x that is equal to 0, z equal to and greater than 8, and initializing, sorry, increment we are plus plus. Port b is equal to my num ray z, okay, This lose for stay in forever and returns 0. One more thing I want to tell you, that you have to use delay of your own choice, but you have to use delay. I will tell you how I use delay here. Look at this. There, I use delay. Otherwise, it may not run properly on simulator. So let me tell you how it looks like on a Proteus. Let me start. I already um, installed the code in it. Here you can see these are 1 and this is 0. Now all are 1. F, all are 0 0. 1 0 0. Like you can see these things. Uh, on about the second complement and one complement, I want to tell you about something. Let me open some file or something. Wait a minute. I will tell you here how to take it. Like what we have 4, and what is the binary of 4 we already know. 0 1 0 0, right? This is the binary of 4, but we are dealing on 8-bit, so we have used 0 0 0 and 0. And taking the first component 1 1 1 1 1 0 1 1. And what we do in second computer, we just add 1 plus 1. What we have here is 0 1, right? 1 1 we get 0. Here 1 again. 1 1 1 1 1 1. You can see clearly like there. I hope it's clear now. So that's all we are doing in our example 7.4. Next example we have to deal with it's 7.9. So let's see about it. Here our example is 7.9. What we are saying in this example, LGs are connected to pin of port P. Okay, write the AVRC program that shows the count from 0 to FF, which means from 0 to 255. Like we are also mentioned 0 0 0 0 0 0 to 1 1 1 1 1 1 1 1 in binary in LED. Okay. One thing I want to mention, every port have 8 pins. Okay, every port have 8 pin, you already know. So what are mentioned in our core and main world, but in the brackets, DDRB is equal to 0xFX, mean we are initializing port B as output, shown in on the screen, you can see it. While 1 is a loop for continue loop for the it is the LEDs or whatever you use using it. Port B is equal to port P plus 1, increment of 1. Delay dala, we add the delay of 500 and wait 0 0.2. Okay, let's move toward the Proteus. Mm, let's see. It is not. Wait 1 minute. I have to bug the code. Build up. Yes, it's built successfully. Let me add it again. File. Okay, it have to work. Why it is not moving? It have to move. Let me see. So here what I changed, the delay was too much for simulation here. So I just less some delay. I give it 100 delay You can see it here, like 100 delay. So that's why it's working. You can see it. It is changing its value. Yeah. So what happening here? It is moving from 0 to 255 here. You can also see the work. Yes, continue, please. Simulator, its main tools for debug, Windows, IO program. We are dealing with port B. Okay, focus it. There, you see breakpoints. You can see it. You're here. There. That's all. Now move towards our example. Example number 7.9. Let's move towards there. Okay. So here is our 7.11 sample. What we are just saying that write a AVAC program to get the bias or data from port C. If it is less than 100, send it to the port B. Otherwise, it will send to the port D. So we are initializing the input DDRC. Port C is input. DDRB output. And DDRB and D are using as the output. Inside char we use temp. You're using here the while loop. Temp is equal to pin C. Pin C means dealing with the pin, any pin of port C. If temp, the what we get the value here, it is less than 100. Then whatever store in temp is equal to port B. It will go in port B. Otherwise, it's stored in port D. That's all. This is happening here. So move toward our next example, that is 7.12. What they are saying, run the following program on your simulator and examine the result. Okay. Okay, we are going to examine the result. What we are using here, we are using three output port B, C, D. And what we're doing, they are using, we using giving hex values, ending or ring, okay, XORing, inverting. While okay, let's see on a Proteus. Okay, so this is the code we are doing dealing with. This is AND function, OR function, XOR, inverting. For this, I have to tell you about something that what how we are using AND, OR, and what's happening here. These are input data of A and data of B, 0, 0, and at A we are given by it given as 0, and it on 0, 1 it given 0, 1, 0 it's given as 0. At one word, it only at one word it is giving 1. If we talk about the OR operation, what is giving, it is only giving 0 at 0, 0. On all the other it is giving at 1, 1, 1, 1. What about XOR? Whenever it is 0, 1 and 1, 0, opposite 0, 1 and 1, 0, it is giving 1, 1. Otherwise it is giving 0, 0. And why inverter? Inverter mean opposite and invert. If we are giving you 1, you give me 0. If I am giving to 0, you give me 1. So it is inverting our output input. So this is output, these are input. You can see it. If I'm giving to 0, it will give me 1, and I give you 1, it will give me 0. This is that. You can see it here. Yeah, you can see it. So let's move towards our example 7.14. So here example 7.14, but they are saying that Write the AVRC program to monitor bit 5 of port C. If it is high, then send the value 0x55 to port B. It is in hex form. Otherwise, send 0xA8 to port B. So we are initializing the port BC as our output and input. We are not using DDR port, so no need to write it here. Uh, in value, what they are saying that if this mask is not equal to 0, for example, here is 1 is not equal to 0, that send this value to port B. Otherwise, else condition will be continue, and in port B 0xAA will be stored. So we'll see it on Proteus here. I already installed the code inside it. You can see here, if I change the value here, if I give here 0 0, what will happen? I will tell you and show you on it. Yes, good. Successfully install it on it. If I click it, it is becoming 0 and all these are 0 0 0. When I on it here, these are some values 1 1 1 1. You can see all this happening. And what I condition is true, that if this mass is equal to 0, then port B is showing some value. Not, then it's not showing. That's it. Now move towards our next example, that is 7.17. So have a look on it. Let's see. So here our example is 7.17. What they are saying that write AVRC program to wait the pin 0 and 1, which means we are already dealing with 0 and 1 pin, only 2 pin of port P, and each one ASCII character to port D. Okay, correct to the following table. This is table 0 0 pin 0 0 1, send 1 1 0 2 1 1 3. Inside code, what are using that unsigned chart storing chart where the temporary value is set, and we are initializing the port D and B, D as output and B as input. In while loop, we are initializing, uh, we are temporary storing pin B value at set, and here this is a mask. We only mask the last two value because they are all said that we are dealing with 0 and 1 pin. So we only mask these two last two values. These are useless to us, so no need of it. We are using the switch here, and there are four cases of it: case 0, case 1, case 3, and case 0 1 2 and 3. There's all four cases of these masks dealing we are dealing. Port T is equal to 0 when case 0, and at case 1 and port and D is equal to 1, and at case 2 port D is equal to 2, and case 3 port D is equal to. There usually we have to use the break here, as we know the C language is important, otherwise it will not okay. Let's see the Proteus simulation of it. I already use it. Let's see here at 0 0, at when pin 0 0, both pin are 0, then we have the value 30 1 1 1 1, sorry, 0 0 0 0 1 1 0 0. If I do it 1, it will is 31. Here is, you can see this pin highlighted red and blue, red for 1 and blue for 0. So this is 33. If I do it 0 1 34. So RSX, this is, you can also do it. So next example we have is 7.25. Let's move towards that example without wasting our time. Here is example 7.25. There is load sensor is connected to the port B pin 1. Okay, and LED is connected to port C in pin 7. Right, the AVCA program to monitor the door sensor when it's open and turn on the LED. So this is a code we're dealing with port B and C, but in my case, I'm dealing with the port B and D. I will show you here. You can see we're doing with port B and D. This is for sensor, this is for LED. This is output, this is input, this is output, and this is input, right? So in our case, I can tell you from there, it is easy and not mix it. That if there is a while loop, if pin B is an AND operation, one is greater than sensor, then this condition will be true. This OR condition will apply, and this will happen. What happens if this condition is true? Then LED will be on, otherwise it will off. What are happening in our Proteus? I will show you this. If the sensor door is not open, 0, it is not open, it is not opening. It is open, 0, it is giving on the LED, off, off. If you on it, it is again on. This is connected to a port D at pin 3. This is all white mapping. If it is open, door is open, the LED will on, otherwise it will off. One, the one you can see. Now to move toward our next example, that is 7.27. Let's move there. So this is example 7.27. Before starting this example, first you have to clear about the term packed and unpacked. Let me tell you. You can see this is the packed PCB. This is unpacked. It means we have to make it pack. How we make it packed? We just multiply and add. We just add 0x 0x 0f to it. We already know that what is ASCII for 9 into is for 2 is 32 and for 9 is 39. Here you can see it also given there. Yes, so we have to make it packed. This is already packed. This from this here we have to make it packed. You can see it in example 7.27. What it is given to us that write a AV or C program to convert the ASCII digital digits of 4 and 7. It means we have to combine and they make it 47. Packed. In fact, we have to make it 47. And to pack BCD and display them on port B. So what we have here, we have unsigned char BCB byte, unsigned char W, which is 4 basically, unsigned char Z, which is 7, and we are dealing with the port B as output. You can see here. What we're doing here that we are AND with 0x0 f, and we are just making it mask. Then we are using shifting operation to make it 34. 4 is basically towards the left we are making, and we are going to move the 4 is towards the right. Now it becomes 0 4, and z is equal to 7. This is equal to, we are using AND operation, adding 0x0f. We are masked by 3. We are masking 3, 34, sorry, 7. I don't know the values, I have already told you about. So what here it is happening, what happening here is that we are just making 0 x 0 0 x 0 0 x 40 to 0 x 07. It's making 47. We're doing this, and this shifting is applied because we have to move it to the left. Yes, that's it. Now our next example is 30 7.30. We're going to move towards 7.30. Let's move it. Here is example 7.30. What they're saying that we have to write the C program to perform the step that if the data is good, it can ask it to character G mean good, and otherwise B for path for D. Okay, here what we do, we have unsigned char. My character, we are using an array of 5 elements. These all value are in hex form. We are using checksum and initialize it to 0, unsigned char, and temporary variable, sorry, char is x, also unsigned. Dealing with the output port D as output, and we are using the for loop for the logic of checksum. It is equal to checksum plus my data array, and add whatever we have in checksum, it will add the value of my array in checksum. If it is equal to 0, if checksum is equal to 0, it means the good. Whatever we have, that these ways, whatever the element we have, it means good. If it is not, if mean there is one or some other thing, then this will condition will do and what we will show. Yes, you can see it on it's what the not showing something here. Let's wait some breakpoints. Here it go down. Not working here. I don't know why. Let me tell you. Okay, this is why. You can see the proteus here. It will be on whatever we have because some value will be shown in store and 40. Yes, you can see. Our next example is 7.31. Let's move to the 7.31 just there. They are saying to us write the AVRC program to convert this binary mean FDX to decimal and display the digital digits on port B, C, D. So let's understand what code are saying to us. We're using condition and this is our function here. Unsigned char X and bin bytes D1, D2, D3. We're saying that the port B, C, D, these all are as dealing we are doing these port B, C, D as output. You can see here bin byte is equal to 0xFD hex byte, binary hex byte, x is equal to binary hex divided by 10 is a condition for you using for D1 is equal to binary percentage sign for 10. Find the reminder. Okay. These all things we are doing with we initializing with port P is equal to D1, port C is equal to D2, and port D is equal to D3. We are moving towards the more significant figure. How did it? Let's move towards. So we have to upload the code here. Let's do it. This is the Proteus simulation. So it's was given to us that it's FD mean 253, right? So in Proteus we can see that is 235 253. That's all. Next move towards our today last example, that is 7.34. Let's move towards there. So here we have example 734. What they're saying to us that if we are C program to bring in a byte of data serially, one byte at a time by port C at pin 3, and least the most least bit should become first. Unsigned chart X RGA temporary initializing with 0. DC inverted for the series pin, one greater than series pin. This is the mass. We are using for loop that is equal to x is equal to 0, x greater than plus plus. If this reg r RGA is equal to RGA greater 1. So better reading that k, whatever the value it have, it must be greater than 1 because we are shifting it towards right. We're using these things, greater and less sign for shifting. For the mouse towards left means we are moving towards right, and if the mouse towards right, it means we are moving towards left. These are the shifting used for the shifting. We are using R is equal to this is our function for copying bit 0 pin of port C to more significant bit. So that's all from today. These all examples of chapter number 7. Thank you so much for Jazakallah khair. Allah Hafiz.